Okay, we are starting lesson 2, and for lesson 2, we're going to be talking about the quadratic function, and what I want you to do is just back up a page so that you're on actually a blank page. So we're starting lesson 2, but I just want to show you what this looks like. So back it up a page. If you have an ID card or something, just draw a couple straight lines so you have a graph. And what we're going to do is we're just going to graph the function x squared, and then we're just going to take a look at what happens. Okay, so use your ID card or a ruler. I got rulers up here if you need them if you don't have ID card. It's just a little bit nicer if it's neat. There are straight edges up here. Okay, and we're just going to do a little table of values and try to figure out what this graph might look like. Okay, so let's do a little table of values for this function f at x equals x squared. And what I like to do is just do a little region or a little neighborhood around the origin. So let's do -2, -1, 0, 1, and 2. So what happens when x is those values? Okay, and what you can do is you can draw in the 1 and the 2, and 2, 3, 4, 1, 2, 3, 4. Okay, so we just got a little bit of a grid getting started here. So let's just do these one at a time. What happens when you square -2? What happens when you square -1? And squaring 0, squaring 1, squaring 2, 4. So do you notice the symmetry in the numbers? Okay, and what would 3 be? 9. And what would -3 be? 9. Okay, so now we can graph this. At 0 you have 0. At 1 you have 1. At -1 you have 1. And at 2 you have 4. And at 3 it's all the way up at, so it's like off the page. So what you get is this U-shaped curve that you've probably seen before, but may or may not know why. So you can see the symmetry from the table of values relates to the symmetry in the graph. And these are called, that's hilarious, because I was writing quadratic. These quadratic functions are called, in the graph anyway, is called a parabola. Okay, and parabolas have use in our lives. In an ideal situation, if you throw an object in the air, it follows a parabolic path. So, who's the quarterback on the football team? This is not Josh? Is that what you said? Okay, not Josh. So he's got a football in his hand. He throws that football up in the air, and it follows, in an ideal situation, it follows a parabolic path. Okay, so they have use in our lives. We're going to study them pretty intensely in this unit. And the reason that we study them is not because parabolas are like one of the most important things and you absolutely need to know about parabolas, but in the second degree polynomial, there's a whole bunch of mathematics that's important for you guys to work with, and it's like a good spot for you guys to start with your algebra. Just degree 2 polynomials, it's a good place to start with algebra. Okay, there's nothing really special about degree 2 polynomials. Like I said, it's just a good place for us to practice. Like if I was trying to teach you how to play baseball, a good place to start would be to put a ball on a tee and try to let you swing a bat and hit it. Well, with algebra, a good place to start is a degree 2 polynomial. You bring me a coffee?
Want a sip with hot chocolate?
Wow, next time you come late, bring a coffee. No, it's 1 cream, 1 sugar. Okay, so let's jump into lesson 2. And again, the quadratic function is this form that you're used to, the ax squared, bx, and c. We've been factoring these since grade 10. Okay, it's a degree 2 polynomial. And in Math 30, you're going to be working with degree 3 polynomials. And then, like when you get to university, it's like any polynomial, degree 4 or 5, like any polynomial. It doesn't matter. Okay. So they've just given you the function notation and the y equals notation. So they're equivalent. So I guess it starts here, and the meat and potatoes starts here. A quadratic equation is an equation which can be written in the form ax squared plus bx plus c equal to 0. What's this? Yeah, it just means that the ABC, which are the coefficients, they're just real numbered. They can be any real number. The coefficients can be any real number. So for example, b could be pi if you want. It doesn't matter. A could be pi. Okay? Doesn't matter. However, you'll always have a 2 on this x, a 1 on this x, and then what's the power on the c? There's an x0 there that you don't see. Okay? Which you don't need to write. Okay, and then the roots and the zeros are the same thing. Okay, so finding roots and zeros is the key. Okay, these terms, general and standard, like they're just loosely based terms depending on the textbook that you're working with, like whatever. Typically, they actually call this standard form the vertex form. So let's just use that. This is the vertex form. Okay, and then you might be asking me, what's the vertex? So if you flip back, what's an interesting piece of this shape? That spot, that lower end spot, right? This spot is the vertex. And the vertex can either be a max or a min. In this case, it's a min, because all the other parts of the graph are larger than it. But sometimes the parabola can be upside down like this, U-shaped but pointing down. So then the vertex would be up here, and it would be a maximum here. Okay. So in this case, at the top it's a minimum, and at the bottom example is a maximum. Not Josh there. Okay, the vertex form, we're going to learn how to create this. We're going to learn how to go from here to here. That's one of the biggest goals of this unit. That's one of the biggest takeaways. Okay, and then if you want to go from the vertex back to the general, well, you just expand this and then simplify. So that's very easy. Expand and simplify. So to go from this vertex to the general, very easy. But to go from the general to the vertex, not so easy. So it's a bit of an introductory lesson. We just did this. So let's do it quickly. Go to the graph. We're just graphing x squared. Okay, we're just graphing this up at the top. So when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is. When x is 3, y is. And then when it was 4, it would be up at 16, so it would be off the page. So you get This is like the positive half of the domain. And then when you do the negative x values, you should get a mirror image going the other way. So you can just plot those quickly. Now you've done it twice. So should recognize this shape. And why do I put the arrows on the end of the graph? Yeah, so like theoretically this graph goes on forever because x has any input. Any input could happen. So if I wanted like, what's the y value when x is 1,000,000,000? Well, you just got to go really far over there and then you go really high up there. Does that make sense? But then like in a science class, if you're like doing data and like putting this on a graph, like you wouldn't put these arrows and you would just plot what you have and then you would graph your data. So in math class, you put the arrows on. Okay. The axis of symmetry. Does anybody want to take a stab at that one? What's the axis of symmetry? It's actually, yeah, it's at the position 0 for sure, but it's a vertical line. Okay, so a vertical line that actually goes right through through the middle of the graph. That's called a line of symmetry. So I'm just going to do that there. Line of symmetry, which they're calling some fancy thing like axis of symmetry. Like it's just so fancy, right? It's just a line, so it's at x equals 0. So vertical lines are x equals a constant. Vertical x equals some constant. So for example, if this parabola was like a little bit over to the right, like maybe like pick up this thing and move it over 1 unit to the right so that the vertex is at 1. Then the axis of symmetry, the line of symmetry, would just go through x equals 1. Does that make sense? Like if I copy and pasted this thing, maybe it will happen. Oh, very cool. Maybe. Copy. Paste. Very nice. So if I move it over here, then I have a new axis of symmetry. Do you guys agree? And it would go through this line. And that would be x equals 1. Okay, so it just depends where your graph is. Okay. The vertex, we talked about that. So the vertex is right at the bottom. Okay, so the vertex, draw an arrow. That's an arrow. Pretty terrible arrow. Okay, the vertex is right here. And on the other graph, it's right there. So it depends where your vertex is, but it's either at a maximum or a minimum. Okay, so it says the max or the min occurs at the vertex and is represented by the y-coordinate of the vertex. So complete the following. So the y value of the function with equation y equals x squared. What? Not the y value. The minimum, thank you. The minimum value of the function with equation y equals x squared is 0. Because the vertex has coordinates 0, 0, and you would use the y coordinate to find that. Okay? So in this example, x is also 0, so it's kind of misleading, but you use the y coordinate to get the max or the min. And then the domain and range, you will always have this. X equals, or x is an element of the real. And if it's been a while since you've done this, put x element of real number system. It just means x can be anything that you could think of. So in high school in Alberta, we only deal with real numbers. There are different systems out there. Naturals is part of the reals. So basically, like if you could think of any number, like basically all the decimals that terminate and all the decimals that don't terminate. So like pi, you know that decimal is just random forever, and then like 1/2 is 0.5. So test decimals that terminate and decimals that don't. And then the range for this one is going to be y greater or equal to the lowest point, which happened to be the y value of the vertex. And then you can put a little comma. Y is an element of the real. So if you don't put that second part on there, like, it's not the end of the world, but this tells you that like the graph is connected and stuff, like there's no holes or no jumps, no gaps. If you were able to just get this thing in the box, or sorry, 2 boxes, just the thing on the left there highlighted, if you were just to get that, you know, it's pretty good. I'd be happy with it. And then comma YER, I'm even happier. But if you just get the thing in the green, that's good too. Okay, so I think that we need to just try some of this stuff and get used to it. Okay, so now they're going to give us transformations. I feel like we need to try a question before we do transformations. Well then. Okay, this one here. In the homework, 1B. We're just going to talk about this graph here. Okay? And we're not going to do what the homework wants us to do. We're just going to talk about the characteristics of this graph here. Okay? So let's go to our graphing calculator and let's graph this thing. I feel like choosing a different one that's a little bit more challenging. Let's do E, okay? Let's do the one at the bottom there. So type in question E into your calculator. Yeah, so what's the issue? If you want to type it into your calculator, y has to be isolated. Agreed? So you got to move that 7 to the other side. So you have x plus 1 all squared. That's like locked in there, right? Minus 17. Do you agree? Okay, and let's put that in the calculator. And let's try to analyze these characteristics. So pop it in over here. We have a x plus 1 in a bracket, and all that is squared, and then we have a minus 17. You agree? If you need to borrow a graphing calculator, I have 1, 2. I have 2 here. I have 2. Otherwise, Emily, you need one? Got one? Everyone else is good? Look at that. We got you, Carl. Don't worry, buddy. Okay, so let's hit graph. And you can see that my window is just completely bizarre. What do you do if your window's completely bizarre? Zoom 6. Boom. Zoom 6. That's a standard window, Zoom 6. So looking at this, you can sort of see the U shape. Do you agree? What can't you see? The vertex. So you need to move it a little bit down. So we're going to go to our window. And which one moves it down? Y min. Good. That's like the low end on the y-axis. So let's maybe double this 10. Let's make it 20. Negative 20. Hit graph. Now you can see it's a little bit lower. And okay, there we go. Okay, Now I'm going to show you these calculator tricks so that you are aware of all of them involving the parabola. So, second trace, and we'll start from scratch. We'll start with number 1 there. Number 1, what happens when you click number 1? Look what it prompts you with. So I'm just going to do some running notes. You can get these before you leave today. So second trace, number 1 value, it prompts x equals. So what do you suppose it's going to do? It's going to allow you to type in any x value you could ever imagine. And it's going to give you the corresponding y value. So let's find the y-intercept. Easy peasy. X is 0. Hit enter. What does it give you? So now you can find the y-intercept every time, no problem, by cheating. Now if it says on a test do it algebraically, well, cheat at first so you know what the goal is, and then show it algebraically so you at least know you're doing it right. Sound like a good strategy? Okay, so there's second trace number 1. You could type in any x value you could ever want. Okay, so I'll type in 10,000. What happened? Why do you think it's invalid? Yeah, because you can't see it on the screen. Okay? So maybe pick a number that you can actually see on the screen. Like -5. When x is -5, y is -1. See how that works? Yeah. What if you have the y but you don't have the x? Good question. We'll talk about that shortly. Second trace, let's do number 2, zeros. You've done this zero stuff already, right? This was lesson 1. So again, if I want to find this one on the left, I got to get my cursor close to it with the left and the right. And then it says a left boundary, so make sure you're left of it, which basically means you're above 0. You see that? Hit enter. And then you want to go to the right of it, so basically it means the y has to be below 0. You basically have to tell the calculator where are you crossing 0. And then you hit enter. See those little arrows there? Those little arrows weren't there before. So now it's telling you to search in that region, and then it does it for you. So there's the zeros. Random decimal, right? .123. Okay, so let's try to get the other one. Second trace 0, and then we got to get way over there. So just, you know, if this was a iPhone or something or a Samsung, and you had an app, you would just click it over there, and it would lock over there, and it would do this for you in a second. But the programming on this is ancient, so it was 5.123 or something. Okay, so you notice the garbage. I had to get all the way over there with tabbing. It's garbage. You know, if you were on your phone, you would you could zoom in you know the window feature? You'd never have that because you would pinch pull zooming, right? On a touch screen, you'd pinch pull, zoom in, zoom out, and then if you wanted an x-intercept, you'd just tap there and it would lock. This calculator on a Samsung is like $1. So you could try and find, I think it's like a hacked version though, so it's not always like, I don't know if it's legal or whatever. But the fact that you guys have to spend so much money on this is garbage, but don't get me started on that. So then the one on the right, I'm getting 3.123. So make sure you can also get that. Okay, so again, second trace menu. Number 2 is for zeros. That was yesterday's lesson. And then I think number 3 and 4 are similar. Yeah, so 3 and 4 are similar. Second trace, 3 and 4. They're identical, just depends which way your graph is shaped. Okay? So in our graph, is that vertex a minimum or a maximum? As it dips down to the low spot and it rises up again, this is like an absolute minimum. Good. So when we go second trace and we want minimum, number 3, Again, it's giving us this left-bound stuff. So where do you suppose I need to be? See this garbage? So I just got to make sure I'm to the left of the vertex. Hit enter. Now it says right bound. Now I'm on the right side of the vertex. Hit enter. And then it says guess. Hit enter again. And then here you have the vertex. Okay, so y is negative 17, and then x is bizarre. So what's up with x? You got negative 1. I got negative 0.999999999999999. No, something's wrong with the random number generator. Did you guys get my joke there? 9999. Something's wrong with the random number generator. Okay, so this 999 crap, it's just like a computer programming kind of process where on these older models, it just, that's the way it ran the, it's like called a floating decimal or something. I looked it up one time. It's just a computer programming thing. So this is just negative 1. Okay? So now you have the vertex. The x is negative 1 and the y is negative 17. Now the last one is the intersect feature, and this is back to Kauser's question. This is number 5, intersect. So she said, what if you have the y value but not the x value? So that's where you use this intersect. So say y was negative 5. And you're like, okay, well, what x value goes with that? So what you have to do is you have to go back into the y equals, go down to like y2, and then let's check out what happens when y2 is negative 5. So you can see negative 5 cut across the bottom there. And she's like, okay, where is x equal to, or what is x when y is negative 5? So now you can use the intersect feature, number 5. And then now instead of saying left bound and right bound, it says like first curve, second curve. So let's go find the intersection on the left. I just go get close to it. If I hit up, I can switch functions. Maybe I'll get there closer, faster. Okay, so now I'm there, hit enter. Second curve, hit enter, and then hit enter again. So that's the x value when y is negative 5. Okay? And that's all the calculator tricks. Okay, so you got your calculator tricks. Let's go back to the lesson. Okay, and now for the lesson, the big chunk of this that's important is these things called transformations. So remember when I copied and pasted and moved this graph over? So that's what we're going to be working on. You have to copy and paste, basically. Okay, so let's take a look at these words and the vertex form. So it says analyzing the function with equation blah. So basically it's analyzing the vertex form. And it says that we're going to do some investigations to explore some transformations. So what are transformations? You guys remember from elementary school? Like rotate, flip, translate. Yeah, so we're going to be doing that kind of stuff. Not so much rotate. But we're going to be doing flips and translates using algebra. Yep. So for example, like if I took all these y values and times them by -1, what would happen? Yeah, the signs would flip and you'd get, don't draw this, but you'd get this. So you can get a flip from a simple multiplication by -1. So that's what I mean by transformations. And transformations is a set of all types of, moves. Okay? So flips and translations. Translations is where you pick it up and slide it, move it left, right, up, down, and then flip is like that mirror, the mirror image. Okay. So let's take a look at this x squared, and then compare it to this one here, y equals f at x plus 3. So what would happen to, if the original function is x squared, what's going to happen here is we're going to get y equals x squared plus 3. So what that means is we're going to take all those original y values, and then once we get them, we will add 3. So basically what's going to happen is if you look back at this table of values over here, you just take all these and add 3 to them. So what do you think is going to happen? Are you going to move down, up, left, right? What do you think is going to happen? Yeah, this is going to be here, and it's going to look like this. It's going to get picked up and moved up. So let's see what the book offers us. And the next one, what would it be on the next one? Instead of plus 3, it would be a minus 3, so instead it would be 3 down. Good. Okay, so this one would be 3 units up. And this one is 3 units down. Okay, so they want us to sketch this on the grid. Okay. So let's move to the grid. And I'm going to use blue so you can see. This original point at 0, 0, where is it going to go now? Let's do up first. 1, 2, 3. Now you're here. This is the new point. And this original point here at 1, 1, where is it going to be? Up 3. So 1, 2, 3. And using symmetry, we got that spot. And then this spot that was at 4, here I'm going to use different colors so you can see the new one. This original one that was at 2, 4 is now going to be 3 up from that. 1, 2, 3. Using symmetry over here, and then you get this. Okay, so it's the exact same graph, just moved up. And again, all that on the calculator, very easy. Check this out. Y equals x squared, and y equals x squared plus a 3. Make sense? If I go zoom 6, it'll look a bit better. There's the first one. There's the second one. Yeah. Not parallel, no. What do you mean parallel? No, it's always like 3 units off. And there's the one that's 3 units lower. Right? They're the exact same graph, just picked up and moved. Mess with your window, play with it, see what happens. Okay, so in general, or let's do these. Let's fill in these charts. X squared plus 3, x squared minus 3. The vertex, the x stays the same, but notice the y changes. And this is a minimum value at 3, and a minimum value at negative 3. Axis of symmetry, is it changing? The axis is, we didn't move it left or right. We're just moving it up and down. So you say this is a vertical translation, 3 units up. So again, you have a vertical translation, 3 units down. And they're just trying to give you what this would look like in general right here. So you have your original function plus some q. And then in part D it says, what is the effect of the parameter q? So what is the effect of parameter q? It's a vertical translation, q units, up or down, depending on if q is positive or negative. Okay, so what happens when q is positive? The parabola moves. And if q is negative, the parabola moves down. Okay, and that blank there is just vertical. You guys ready for the horizontal ones now? Ah! Okay, so now jump into the next one. So what's different about this one compared to last page? See this one? Did we change x on this one? No. We were changing y because we were taking our f at x and adding an extra value, which in fact changed y. Now for this next page, what have we done? We've changed x. And I'm just going to give you the surprise right now, the surprise twist. It's the opposite of what the equation says. So see how we put a plus 3 in the equation? Wait for it, wait for it, wait for it. The biggest surprise twist you ever did see is 3 left. Okay. And this one here, 3 right. And Chi Ming just spotted on for us. If we put in the vertex form that they've given us, what is in the vertex form? And I'll draw a big blue arrow pointing to it. What's always got to be there? The minus is in the form. And this really throws off students, especially those that don't practice. This is one that'll get you if you don't remember it from now. The form has x minus. So if it says x plus, you must have inserted a negative. So you go minus minus, it becomes plus. So we've inserted a negative 3. That means 3 to the left. Can we all memorize that? It's opposite in the equation for the x only. So I always tell students that it's like counterintuitive on the x, but it is what it is. So let's go to this. Well, let's draw these pictures. 3 to the right, 1, 2, 3. Just give it a good sketch, whatever. And then 3 to the left, 1, 2, 3. There it is. So this is f at x plus 3. This is f at x minus 3. Okay? Doesn't have to be perfect. Just to get the idea. Kind of run out of time. And I apologize for teaching right to the bell, but we kind of had to today because I showed you those calculator tricks. And if we need more time at the end of the unit, we should be okay. I've been doing that this whole year, right? Okay, so let's take a look at this chart. When you look at the function itself, this is the first row. It says y equals f at x, and then you get y equals x squared. So if you think about that, that means x squared is f at x. So what's the rule of this function? What's the rule of this function? This is so critical. What's the rule? What do you do to x? You square it. And what is x? It's the thing in the brackets. It's the input. So take a look at the next one. What is inside the bracket? So then your new function is x plus 3 squared. Whatever's in that bracket, you're going to apply the rule to it. And the rule in this case is take that input and square it. So what's going to be the next one? Take that input and square it. Does that make sense? This is some of those baby steps in algebra. Like if you didn't know that from Math 10 and now you do, well, you just leveled up. Now you're level 2. Prestige, baby. Okay, so what happens to the vertex? What happened to these vertices? What happened to them? They move to the left and the right. So the y value in the vertex does not change. But the x values do. So for the x plus 3, you went 3 to the left. And for the x minus 3, you went 3 to the right. And these stay the same because we didn't change the y value. So those ones stay the same. Remember, it's the y value. Why is Norvisi laughing? What did you say? Okay, now what is changing is the axis of symmetry. Now, I'll just jot in the answers and then you tell me why. Why is it -3? Well, just look at the vertex. Yeah, the axis of symmetry, it just comes from the vertex. It's so obvious. The vertex is in the middle, do you agree? And vertical lines are x equals some constant. So use the x value. Where is it? Right here. Remember this? Vertical lines are x equals some constant. So just use the x value of the vertex. X value of the vertex. Okay, so what is the parameter? What is the effect? What is the effect of this p? Horizontal translation. P units, left, right. Good. Which is basically exactly what this says here. Now, if P is positive, the parabola moves right. And if P is negative, the parabola moves left. Even though the equation says otherwise. Don't believe the equation, right? So the equation says otherwise. Don't believe it. Be smarter than that equation. Next page. Oh my god. Okay, this one just does both at the same time. Okay, so what's our rule? Take our input and square it, and then -4 after. The vertex will be -2, -4. That's one of the key outcomes from today. If you can take a look at the vertex form and then get the vertex fast, then you've had success today. You've leveled up. Opposite of the x, -2, and then the y is what it is. So the p and the q. Yeah. Okay. So if it says plus p, it's a minus. And if it says minus q, then it's minus q, and it's good. So the q is what it is, and the p value is opposite. Again, this is a minimum, but where's the value? -4. It's the y. And the axis of symmetry is the x. And the transformation would be 2 left, 4 down. So with that in mind, let's see if we can get these ones done quickly. Class example 1. what's the p-value for class example 1a? Negative 10. So left 10. P is the transformation on x. So I'll write the form right here. X minus p squared plus q. Right now we're not even talking about the a value. I think that's next lesson. Right now we're only focused on the translations p and q. Okay, so take a look at the next one. Is it a p-value or a q-value, that 4? See how it's not on the x? It's not in the brackets. Good. So q is positive 4, so it's up 4. Now what's up with c? Yeah, let's move it to the other side there, and then it'll look more familiar to us. So that positive 8 is going to become a minus 8. So now with p being positive 5 and q being negative 8, then you can see that it's 5 right and 8 down.
All participants in the pep rally, please go to the large gym. All participants, athletes in the pep rally, go to the large gym.
Just take your valuables. You have valuables? You have valuables? I'll take your, if you want me to hold on to the valuables. Okay, you guys ready to finish this off? Okay, 5 units right. That means the p-value is positive or negative? The p-value is positive 5. So when you go to put it in this vertex form up here, you should have y equals x minus 5. For part B, 6 units down, that means q is negative 6. And p is negative 4. So when you go to put it in the equation up above, up here, see where it says minus p? Well, you're going to do a minus 4. So that becomes
Plus 4.
x plus 4 is all squared, and then we go minus 6 after. At this point, you should be like, okay, plus 4 in the x, that means 4 left, negative 6, so 6 down. 4 left and 6 down from that original graph. What's up? Only on the x.
Staff and students, please, pardon the interruption. If we get you just to hold your classes, we will call down when it's time to get to the pep rally. So please hold your classes. Thank you.
Okay, write the coordinates of the image of the point 3, 9 on the graph when a translation is 2 units up and 7 units right. So 2 units up, what would you do to all the y values? All the y values, you'd have to add 2 to them. And if you're going 7 units to the right, you would take all your x values and add 7. So that's what we're going to do to this 3, 9. 3, 9 is going to get mapped to 10, 11. How was that? Because you have to go plus 2 on the y and plus 7 on the x. That would be if you're doing every point one by one. Each point you'd have to map it over, do the translation, pretty wild stuff. And actually, this is pretty cool that you're doing it now, because in Math 30-1, there is a unit called transformations. And you literally do this kind of stuff for the whole unit. This is only just the first part of quadratics. And the assignments. So, okay, so let's do everything, because it's very small. So until we get called down, you might as well just work on this small assignment.